I am Anil Kumar. Welcome to our series on Inspired by Math. In our last video, we have explored how do we figure out the prime numbers less than 100 using a special prime diagonal grid. Now we'll try to analyze patterns within the prime numbers. We're looking at twin prime numbers, which are just two apart, like best friends on a number line. We are going to list these twin prime numbers. Also, let's go through a simple process of identifying the prime numbers. We have a chart which is very special. It is having six columns instead of 10, the standard 10. Why it is so? Since it highlights the beauty of numbers even better. Great. Now, since 1 is not a prime or a composite number, we'll just cross it out and strike out everything which is multiples of our small prime numbers like 2, 3, 5, and 7. So we leave aside 2 and cross out these multiples of 2, which are even columns. So in this case, 4 also gets striked off, and then 6 also gets striked off, along with all the even numbers gone. So the only even number which is prime is 2. Perfect. Now the multiples of 3 means third column goes away, sixth column is always out, already out. Great. Now multiples of 5, which is not difficult, but see how they are placed on this special grid diagonally, and that gives its name, which I have originated, diagonal grid for prime numbers. So we put this diagonal from 5, and of course I should not cross out 5 since 5 is a prime number. So all multiples of 5 will be crossed out. So once you reach at this number, which is right here, then the next series starts with numbers are too small for me. Okay, so this is 25, starts with 30, right? So this is the column 35. So then 40 diagonal, right? So that's the end of the diagonal, correct. And then 90 diagonal, correct. So basically, you come to the other end of the same row, and then the diagonal can cross out all the multiples of 5. So you see how beautifully the numbers are written in this particular grid. Next is 7. As far as 7 is concerned, look diagonally from 7. So going down and right? So leave 7 aside. Well, we can circle 7, right? Leave 7 aside and then go diagonally, striking out all the multiples of 7. So once you reach at the end, then what you need to do is come back to the next number, which is 49, and go diagonally to strike out the rest. And then we have 91 and 98 striked off. What remains is all prime numbers. So let me highlight these which remain, right? So they remain, correct? So in this list, these are the numbers which remain, which I am highlighting. So in this list, we have 25 numbers which will be remaining, right? Right. So once we highlight these numbers, we'll get twin primes. I'm also highlighting 101. So twin prime basically means the numbers which are separated by 2. So as you can see, to begin with, we have one twin prime right there, which is 3 and 5. And you also see 5 and 7 is also a twin prime. So let's write down the twin primes. So the first twin prime is 3, 5. And then we have 5, 7. Correct. After that, what you observe is all the prime numbers are either in our first column or in the fifth column, right? So they are twin primes, right? So we can now make combinations of each, right? So for example, 11 and 13, right? 17, so we for example, 11 and 13, right? So we have 11 and 13. So how easy it is, right? 17 and 19. And then we have 29 and 34. So alternate, right? So I'm only highlighting and writing down the twin primes. I'm leaving aside the other prime number. I left 23, right? You notice that, correct? So we have 29 and 31. Okay. And then we have 41 and 42. And after that, we get this number, which is 61 and 59. Correct. And then we have 71 and 73. So we are only listing twin primes. See how easy it is, right? And then we have, I think that's it, right? Okay. The next number is 101 and 103, which is greater. So these are the twin prime numbers which we have very easily listed from our diagonal grid. Now, what makes them special? So few special things are that you will notice that 5 is actually in two twin prime numbers. So 5 is kind of an exception. 3 5 and 5 7. In all others, twin primes, we have a very special property. And that is that if you add them, right? If you add, what you get? If you add the prime numbers, what you get is that their addition is a multiple of 12, right? So we note that add is a multiple of 12. In fact, all these twin primes which we have listed, apart from the very first one, which is 3 5, the twin primes are following this particular formula: 6n minus 1 and 6n plus 1. Makes sense, right? You saw that all the prime numbers were on either side of the sixth column. They were either in the fifth column or in the seventh column. So, the beauty of this particular grid is that it just gives you the rules, and that is Kaprekar's way of working, and that is what we are calling inspired by math with us mathematicians like Kaprekar. So we enjoy the beauty. The numbers themselves give us what they are, and that's the beauty of mathematics, which you learn with inspired with math. So next time you spot two twin primes, check their sum, check their middle, ask if it is a multiple of 6, and if yes, you have just found another prime whose sum is a multiple of 12. So on either side of 6 multiples, you will get twin primes, and that's the beauty. Perfect. So twin primes are a whisper in the universe of numbers, inviting you to look closer, think deeper, and ask what other secrets are hidden in this particular grid. So I hope you enjoyed this grid and the beauty of the grid, which actually pops up the prime numbers, and this time you saw how it reveals even beyond looking at twin primes. Thank you and keep watching our videos, subscribe to them, and ask for a sneak peek into our book, Inspired by Math.
Inspired by Math is for curious minds, creative thinkers, and junior mathematicians ready to explore the world with numbers. Whether you're a student, a parent, or a passionate educator, this journey is for you.